Hi, everyone. I hope you're all doing well, and some of you may be recovering from APA and just getting settled into your classes. So I hope all of that is going well for you guys. So this week we're going to be working on Lab 3, and hopefully next week for Lab 4, I'll finally get to see you guys in person. So let's go ahead and get started. Alrighty. So the first thing we're going to do is go into our Canvas to modules, and under lab exercises, we're going to be opening Lab 3 combined file. All right. So once we have that open, we can go ahead and go over today's objectives. Number one, we're going to be entering data into SPSS, understanding SPSS files structures, learn how SPSS handles different levels of measurement, learn how to select cases from SPSS, and learn how to recode existing data to create new variables in SPSS. So for this week, we're going to be using the handout, which is actually attached at the bottom of this, and the demo.sav file. So let's go ahead and scroll down because the first thing we're going to be doing is entering some data. So go ahead and pull this up on a separate screen and we'll go ahead and get into SPSS. So we should know by now that we're in the My FSU VLab. And to get started, we're going to create a new data file. Sometimes data is available in electronic file format. Sometimes you have to create a file to conduct your own analysis. So today we're going to be creating an SPSS data file from population data obtained from the Tallahassee-Leon County Planning Department. All right. So we're going to be adding the planning area ID, population in 1990, population in 2000, population forecast for 2010, and population density forecast for 2010 measured in persons per acre. So the file data should contain a total of 9 cases and 4 variables. So, and we're not going to include the total variables for this as well. So to go ahead and get started, we're just going to stay in our data view and click on variable, double click. All right. Under name, we're going to enter the following IDs. So the first one we will have will be ID. After that, we will have P 1990, P 2010, and finally P underscore A 2010. So after we have that, we're going to want to change the types. So the first one we have is going to be string, and then we'll hit OK. We'll keep these 3 as comma, and the last one, the PA 2010, will be numeric. All right, so after we have that done, we're going to go to the labels and go ahead and label them accordingly for 1 through 5. So planning area ID, population in 1990, population in 2000, in 2010, pardon me, and population density forecast. Persons per acre. Alrighty, so after we have that, we're going to change the ID as nominal and change all the others to scale. Perfect. So after we've created our data file, we're going to save it with a new name and we're going to call it planningareas.sav. I'm just going to put my initials after. Save. All right, perfect. So the next thing we're going to want to do is using this data right here at the end of the Lab 3, we're going to fill out our variables. So we're going to do planning area. We're going to skip over 1987 and just do 1990, 2000, 2010, and 2010 persons per acre. So go ahead and do that now. I'll give you a little demo. All right, and we should have 9 lines. So after we do that, we're going to go into P1990 and type in each number individually. And so on until we have all of it filled. So after we have all of the cells filled, we're just going to go ahead and save it again, just to be safe. Alrighty. So to display the data structure of the file, we're going to now click, following the click steps, File, Display Data File Information, and Working File. So that's going to come up in our output, and it should look something like this. And you can see that now on the second page of the instructions for today. So the next thing we're going to do is to select cases using SPSS to calculate values of a new variable. So planning areas 6, 8, and 9 on the map we saw below are located in the urban fringe of Tallahassee. Suppose we want to examine forecasted growth between 2000 and 2010 for only Tallahassee's urban fringe. We also want to know what share of forecasted urban fringe growth will be contributed by each of these planning areas. So we're going to use the SPSS to create a second data set selected from the set we just created and have SPSS calculate new variables for us. So we're going to first select the 3 planning areas out of a larger data set to create a new data set called PA689. Then we'll create a new variable called T growth containing the forecasted population growth for 2000 to 2010 for planning areas 6, 8, and 9. And finally, we will use the new variables to make a pie chart depicting the contribution of total urban fringe growth by each planning area. So to follow click steps, first we're going to go into the variable view over here and change the variable type for variable ID from string to numeric. So just like we did before, we're going to click it twice and change it to numeric and click OK. Then we're going to select areas 6, 8, and 9. We're going to go to the data menu and click select cases. So data and select cases. Perfect. So we're going to click if condition is not satisfied, and then we will click if and enter in the box. We're going to put move ID over here, and then we will click the equals and 6 space type or space, click ID again, equals 8 space type or again, another space, ID, bring it in once more, and we'll have that equal to 9. After that, we'll click continue. Under options, you can tell SPSS how to treat unselected cases. One option is to filter the cases, which is the default. Filtering removes the cases from your analysis, but retains the information from the data file. Click OK and go to your data view. Back to data view. And now we can see that the ones that we have not selected are crossed off, only highlighting 6, 8, and 9. So after that, to restore filtered cases, you can go to select cases and then hit the reset button at the bottom of the dialog box. Alternatively, you could instruct SPSS to delete the unselected cases. Under output, select delete selected cases. And this permanently removes the unselected cases from this file. So now that we have this, we're going to go ahead and save it as a new file. And this is going to be called PA689. And I'm going to put my initials after. You don't have to do that. And we'll click save. Alrighty. Moving on to add the new variable, we're going to click transform and compute variable. After that, we're going to write in the target variable of t underscore growth. And the numeric expression we're going to use is the 2010 to P2000. So P2010, and then you can click the minus symbol on your laptop, and then P2000, and move that over. And we're going to click OK. So once we've done that, we're once again going to save the data set. Great. And to create a pie chart for the new variable, we're going to click on Graphs, Pie, keep summaries for groups of cases selected. We're going to define that. Under slices, we're going to click the sum of variable and select the new variable here, which is going to be our t growth. Under define slices by, we're going to select area ID variable and assign the title, and we're going to call it share of urban fringe growth by planning area. Click continue. And then we'll click OK. And now we have our pie chart. So to format the pie chart, we're going to do the same thing that we did in a previous lab. So if you need to reference that, that's fine. But by now you should know how to do it. So we can double click it to go into the chart editor, double click again. We're going to do gray for 6, black for 8, and then we will click white for 9. All right. So once we have the colors correct, we're going to go ahead and add the percentages. And to do that, we're going to click Elements, Show Data Labels, and move % up and exit out of T growth. And click Apply and close. So now your Elements, Show Data Labels. There we go. For whatever reason, it only wanted to do one slice of the pie. So once your pie chart looks something like the one that you're seeing in the lab handout, we can go ahead and move on to the next step. So after this, we're going to move to recording variables. So when we have very large data sets where observations take many different values, it's sometimes useful to record the values into groups. For example, we might take age data where observations are recorded in years and recode the data to create a new variable where the values represent ages or groups of years. When we recode variables, we can change the variable's level of measurement. For example, we might take age in years interval level data and create a new variable of age ranges, ordinal level data. That's what we're going to do. We're going to recode interval level data and create new ordinal level variables. We will use the data from demo.sav, which you should all have saved, and create a new variable of respondent age groupings. We will create 10-year age ranges, starting with 18, the minimum age, and ending with 77, the maximum age. We will call our new variable age2 and save the data to your disk and create a new variable. We will then produce a frequency table that displays our new variable. So to follow the click steps, we can go ahead and keep this open if you like, exit out if you want, but we're going to go into File, Open, Data, and find our demo.sav wherever you may have it saved. And we're going to open that up. So we're going to go ahead and recode the variables. And to do so, we're going to click Transform, recode into different. So we'll click, once we're here, we're going to click age and move it over into the input variable. And the output variable's name will be age 2. We'll click change to bring it over. We're going to click. So now that we're in the old and new values box, we're going to click range. And we're going to do our first set of ranges, which is going to be 18 to 27, and give that a value of 1. After we have that in, we're going to click add. And now we're just going to go through our age groups. So after that, we'll have 28 to 37 with a value of 2. And then we'll have 38 to 47 with a value of 3. And then 48 to 57 with a value of 4. 58 to 67, the value of 5. And lastly, 68 to 77 with a value of 6. Click add. And after that, we can go ahead and click continue and OK. All right, so go back to the data view of your set, and there's a warning on here that says, remember that H2 is a new variable consisting of 6 intervals. You will need to tell SPSS the age values for each interval. Otherwise, the chart will only show bars numbered 1 through 6. You need to value label each interval. So to do the value labeling, we're going to get into the variable view, and it will be at the bottom. So go ahead and scroll all the way down to the bottom. And under the values tab, there's going to be a button on the right, and go ahead and click that. Click add on the right, and the first thing we're going to do is type a 1, and our label will be 18 to 27. So just like we did before, we're going to add our age groups with their values. So 2 will be 28 to 37. 3 will be 38 to 47. 4 will be 48 to 57. 5 will be 58 to 67. And 6 will be our last age group of 68 to 77. So once we've repeated this process, we're going to click OK and produce a frequency table. So to remember how to do that, we'll go back to our data view. We will click Analyze, Descriptive Statistics, Frequencies, and we'll use age 2 as our variable and click OK. And here we have the age 2 frequency table, and it should look like the same one that you have in your handout. All right, so that sums up Lab 3. I hope you guys all have a great weekend, and I'll see you next week.